Wonderful to be here today with everyone. I wasn't prepared for a brief bio, so I'll keep it really brief. My name is Stephanie Gandulla, as Hans mentioned, and I'm the research coordinator and a maritime archaeologist for Thunder Bay National Marine Sanctuary. And what a treat this conference this week has been so far, and looking forward to the remaining presentations. The keynotes have been outstanding. Learning a lot and compiling a whole bunch of links I'm looking forward to researching and diving into. But I would like to start out by acknowledging that Michigan occupies the ancestral, traditional, and contemporary lands of the Anishinaabe, the Three Fires Confederacy of Ojibwe, Odawa, and Potawatomi peoples. In particular, the Great Lakes Maritime Heritage Center, the headquarters for Thunder Bay National Marine Sanctuary, just a few blocks from where I am right now, resides on lands ceded in the 1836 Washington Treaty with the Ottawa and Chippewa nations. And if we could change to the next slide. This may sound a little familiar throughout this week, but Thunder Bay National Marine Sanctuary is the first freshwater national marine sanctuary in our country and part of a network of sites encompassing more than 600,000 square miles of marine and Great Lakes waters in 15 sanctuary sites and 2 marine national monuments. Since 1972, sanctuaries have worked to protect these special places in America's waters. And the work we do, the work we'll be talking about today, is backed by the National Marine Sanctuaries Act, one of the nation's strongest pieces of ocean and Great Lakes conservation legislation. And this really drives our initiatives to understand these special places we protect. And what better way to understand them but to map them? Next slide, please. I did mention that we were the first freshwater national marine sanctuary. We gave up the title of only very recently to welcome the Wisconsin Shipwreck Coast National Marine Sanctuary and hope to welcome Lake Ontario soon. My sanctuary colleagues have already talked. Thank you, John, Russ, Maddie, and Phil will talk later today about the growing significance of the sanctuary program in the Great Lakes. So instead, I wanted to just briefly touch on how accessibility, particularly in Thunder Bay, can lead to people really connecting to these resources that we're charged with protecting, and thus connecting to the place, to the ecosystem. This engagement is a part of what drives public support for our projects. Simply said, fostering accessibility really fuels more mapping. As we continue to develop these partnerships and the robust outreach that Dr. Nicole Renaud referenced in her keynote yesterday, and continue to develop the public accessibility of the mapping data facilitated by GLOS, by NCEI, by NCOS, and of course this Lakebed 2030 community, it really feeds the drive to map as our initiative, our mapping initiatives, chug along with more and more public support. So next slide, please. Bringing us back to this talk's project location, let's zoom into Thunder Bay and remember why it is indeed such a special place in the lakes. Designated in 2000, the sanctuary started out as 448 square miles and now encompasses 4,300 square miles of northwestern Lake Huron. As we change to the next slide, we can see why we're significant because of the sheer number of archaeological sites. And if we could go to the next slide, we'll be able to see all the dots on the map that really highlight how many shipwrecks we have. So of course we're significant for the quantity of shipwrecks and the preservation possible in the cold fresh water. But as I alluded to earlier, the feature that makes this collection truly significant and thus relevant is the accessibility. Whether visiting a shallow site on the glass bottom boat or taking a virtual 360 dive from your living room, people are connecting to and caring about sanctuary resources. Next slide, please. And our management plan clearly dictates our mission to protect both cultural and natural resources in sanctuary waters. It also outlines a smart strategy to develop partnerships to do this. In just 1 year after sanctuary designation, one such partnership has over and over throughout the years proven its value. Next slide, please. A major Sidescan Sonar survey covering approximately 240 square miles of the sanctuary was undertaken in 2001, so just 1 year after designation, by Robert Ballard's Institute for Exploration. The team confirmed the locations of 15 sites in and around the sanctuary, produced the sanctuary's first sonar images of these sites, discovered at least one shipwreck and a submerged sinkhole in 300 feet of water. This effort covered nearly half of the sanctuary's area at that time, primarily offshore. And you'll see in that photo, Sanctuary Superintendent Jeff Gray working alongside Dr. Ballard and Dwight Coleman, who led our survey project this year. So not only did this partnership to map the new sanctuary help set a baseline for further exploration, it really put the sanctuary and the Great Lakes on the map, both in research and exploration spheres, but also in the public sphere. Next slide, please. The man who discovered the Titanic was now discovering shipwrecks in Michigan. Pictured here is the shipwreck discovered in that 2001 survey, the Corsican, a wooden two-masted schooner that sank in June of 1893, all lives lost. Today, the shipwreck site lies at about 160 feet. So almost 20 years later, the partnership continues with Dr. Ballard's Ocean Exploration Trust, conducting mapping operations in the sanctuary in both 2019 and 2021, just this last June. These recent projects have brought some amazing expertise to Northeast Michigan, including that of my friend Erin Heffron, the project's mapping coordinator and currently the lead navigator on the Nautilus expedition that we enjoyed a sneak peek into yesterday. Erin was an invaluable asset to both of the mapping projects in Thunder Bay, and I'd like to pass the mic over to her now. Erin, you've got the bridge.
Hey, thanks, Steph. So as Stephanie said, my name is Erin Heffron. I am an ocean mapper by training, background in GIS and geology, and I'm also a navigator on exploration vessel Nautilus, which is where I am right now. I'm in our control van in the studio, and if I just flash over quickly, if you're looking at what was my face, that's our back deck. We just came into port after an expedition, which I'll mention briefly. So if you're familiar with Nautilus at all, you might be, or Ocean Exploration Trust, you probably might be familiar with Nautilus Live, and that's how we broadcast everything we do to the world. So when we are mapping or doing dives, we're always sending that out through telepresence and interacting actively with people on shore. If you are not familiar, we do have a great set of internships for science, mapping, engineering, and outreach. We do fellowships for educators, and always trying to bring as many people as possible on board to have fun with us, and also from the shore to connect with us and be part of this. Nautilus is a 68-meter long vessel, 17 crew, and we have berths for 31 scientists. And we just completed a mission with the Ocean Exploration Cooperative Institute partners out of Woods Hole, and we were testing some missions with their Mesobot, which does midwater water column mapping, and the Nereid under ice vehicle. So just a flashback again to our back deck. That back deck up until about 2 hours ago was chock full of other little robots, but they mostly got those off. So we're getting cleared out and ready for our next mission. So if I can have the next slide, please. So we have a sonar on our ship as well, just to be clear. We do a lot of mapping with our EM002. And I just wanted to point this out. This is a lot of mapping we've done off the west coast of the US. The colored stuff is what we've done. And the purple underneath is the bathy gap analysis that NOAA has done. And so we're always trying to fill gaps when possible with our sonar. Next slide, please. M001 with Thunder Bay was our first mobile expedition, and this was with Stephanie and our partners at Thunder Bay. We couldn't take Nautilus there. That would be a tricky situation to get the ship there. So instead we sent our team, as far as communication folks and mappers and expedition leaders, to Thunder Bay to be part of this. We also then partnered with our colleagues at UNHCCOM, also part of the Ocean Exploration Cooperative Institute, and they brought their autonomous surface vessel Ben, which I'll talk about a bit more in the next slide. And we partnered with the Great Lakes Environmental Research Laboratory and used their RV Storm, which also had a sonar and EM2040 pole mounted. And we also got support from the 3011 NOAA vessel 3011, and that was our kind of support vessel for that expedition. Next slide, please. So just to talk a little bit more about ASV Ben, It is an autonomous surface vessel. So on the top right, you see it as this little yellow boat. It has an EM 2040, and the top center is my head under the 2040 checking it out. So it's a small sonar for shallow water mapping. When this little boat is in the water, our captain on the Nautilus thinks it looks like a duck. So there's a little ducky attached to the top now. And they travel, the team that runs the ASV travels with this beautiful control van that's really set up to do mobile operations. So on the left, you see me monitoring the sonar. So while the vessel's out, we have control over the sonar. We also have 360 camera views. And the bottom center photo is Roland, part of the ASV team, driving the vessel. So you have control from there as well. They can drive it, and just beautiful screens, beautiful setup, really, really nice to work with. Can I have the next slide, please? So that first expedition in 2019, between ASV Ben and the storm, we were able to do 170 square kilometers of mapping of unmapped area within the sanctuary, focused in around Rogers City. So in that map in the middle of the yellow outline is Thunder Bay. And then zooming in on our mapped areas, and it's hard to see, there's a red outline around one portion of the survey, very difficult to see, but that's what the storm did. And then the black outlined areas are what ASV Ben did. And then that inset is some of the storm's 2040 data, just over some really beautiful like pockmark type features on the lakebed. Next slide, please. All right, so 2019 was very successful, got a lot of data for the sanctuary. We got to come back. We were going to come back in 2020, but things got crazy, as we all know. So we returned in 2021 for actually two expeditions, M002 and M003, two mobile expeditions, again, supported by Ocean Exploration Trust. But because we did not have our vehicle or our ROVs there, we brought in a lot of partners. So again, talking about the importance of partnerships. So the ASV Ben returned with the CCOM UNH team. The 3011 was also there to support us, very important part of our operations, shockingly important. And then the storm was not available, so all the mapping that happened this year happened with ASV Ben. And our primary goals with the mission this year were to fill in some gaps. So those red boxes over the map are some gaps that we would like to see filled in. And also to do some mapping in support of the ROV expedition to follow. So we were going to be doing ROV work over known artifacts or wrecks. And so we were going to try and run some multi-beam over that just in preparation for the ROV work. Next slide, please. So I actually think I'm going to talk about the challenges, because I think the results are important and great and were totally interesting and beautiful, but I think we learned the most from the challenges that we have on these expeditions. And so one of our big challenges was ASV Ben, also in 2019, but we really started to nail it down in 2021, is our telemetry, or our ability to communicate with the vehicle from our shore-based station. The vehicle can run missions completely independently. It can be driven, could be sent missions on the fly. So there's a lot of opportunity to change things. But we like maintaining communication, even if it does have its own plan all ready to go. And so we found that our telemetry range, our ability to send that communication, we have radio communication, Wi-Fi, and Bluetooth, really changed daily, and it wasn't super easy to predict. It was environmental for sure, but even when we thought we understood when we were going to get good telemetry, it sometimes surprised us. So the picture on the left is an example of good telemetry. We got out to that outer gap, we mapped there all day, and then we came back. That was great. The image on the right, it should say bad telemetry day, not good. We would head out, we were trying to get out to one of the further gaps, and we start seeing our signal drop out. So we immediately kind of turned around, that's a little jog, decided to map inshore that day. So that pretty much was how every day went. We would try and push for the outer polygons. If we couldn't quite get there, we would turn around and do some work inside a bit. And that was just definitely challenging. Next slide, please. And we knew that that was going to be challenging for the other priority, which was mapping over these known wrecks. They were all quite a bit further out than the area we had been mapping, and we knew there was probably no chance we were going to maintain consistent telemetry. So we went back and forth on ideas. We thought about moving the whole mobile control station closer so that we had a better connection but via the antenna. And we just couldn't really get any closer. So we decided, not the most efficient use of 2 boats, but it did work. We decided to use the 3011 as a mobile station to support the ASV. So the ASV team, here you see Val Schmitz and KG in the top left, KG Fairbarn. They took exactly what they needed to control Ben. They also took the CTD out, which we'll talk about a bit more later. And they just followed Ben around and sent him out on this mission to map Rex. And so they were there to support it. You can also see Steph driving the 3011, keeping up with Ben there. And then, yeah, they mapped over it. So on the right, that is a map, I believe, over the Merrick, which is one of the known wrecks and one that we had planned to dive on. So again, not the best use of 2 vessels, but it did work. And we were able to get really good data and just do a solid day of mapping out there to really focusing on these wrecks. Next slide, please. Our second big challenge was sound speed. And this, I guess we were just paying better attention this year, but it really kind of took us for a loop, how much the sound speed changed in the water column throughout the day and day to day. So on the right, you see a messy plot of all of our profiles or casts down through the water column. And so something that I haven't mentioned, but very important, is that Ben has a sound speed sensor by the transducer, which is important for beamforming, but it has no way to do a sound speed profile through the water column. So on normal days, on most days, we would support that by sending out the 3011. So the 3011 worked really hard this year because we had to do so many casts to keep up with the variability that we were seeing. And so in the pictures on the top left, you see an experiment that the ASV team was trying to do to be able to deploy a profiler from ASV Ben. Didn't quite work, so still working on that, but that is the goal, that we wouldn't have to have this support vessel following the autonomous vessel. And the 3011 would go out, and some of our supporting team members would do a CTD cast close to Ben, or where we expected Ben to be within 30 minutes or so. And then they would go chase Ben. It was quite exciting. We could see in the bottom center, that's the view from the cameras on Ben. We could see 360 view in the control station. So we would watch the 3011 approach, and they would hold out the CTD, and with a Bluetooth connection, we'd be able to send the profile right into the ASV and get it into our data real time. So that was pretty cool. We ended up doing, I think, 50 plus CTD casts. That's what you see on the left. Just crazy variability, and I think mostly due to the warming top layer of the surface. But even as you got past that warm layer, there was still quite a bit of variability in the sound speed. Next slide. And then this weighed into another challenge. So as we started to process the data, we were just seeing so many artifacts on the outer edges, and it really had us pulling out our hair because we were concerned there was something wrong with how we had integrated the system. We were concerned the transducer was moving, that something was going on that was leaving these pretty serious artifacts on the outer edges of the swath. So Val Schmidt, who is the lead for the ASV team, contacted his and our colleague at University of New Hampshire Center for Coastal and Ocean Mapping, John Hughes Clark. We asked him to take a look at our data, and his prognosis, which made us feel a bit better, is that it's just the lake conditions, what we would call the oceanography out at sea, but now we're in a lake. And so there's just a few profiles there on the right. And what he thinks was happening is that we were hitting a pretty sharp V-decline, or a pretty sharp change in sound speed, really high up in the water column and just at the level of the ASV's transducer. And the profiles we're doing can't possibly capture that level. You just don't get that top part of the water column with the sensors we were using. So we couldn't really do anything to correct for it. So it was basically like we had to pull our swath in, which I'm sure if any of you guys do some mapping in not so perfect conditions, you've done that before. Just pulled your swath in so that you weren't getting so many artifacts in the outer edges. But it was really interesting, really great support from John Hughes Clark to run that analysis so quickly and to make us feel better that we were doing the best we possibly could for that survey. Next slide, please. So the results this year, again, it was just Ben mapping, not storm. So we got 74 square kilometers. That shouldn't be combined, it was just the one vessel. And as in 2019, we did bathymetry mapping and seafloor black scatter everywhere. I don't have a backscatter image here, but it is beautiful. And so that's great because we're getting the lake bed, we're getting the backscatter, which is great for habitat mapping. We also were collecting water column backscatter, but because of the size and bandwidth issues with our remote connection to the vehicle, we limited water column to areas over known artifacts, or if we saw a target of interest, we would turn the water column on. On a ship like Nautilus, we run the water column all the time, but it's much lower resolution because we're in much deeper waters. So we did run the water column, and you see we hit most of our gaps. We did end up leaving one out there in the outer edge, but we'll just have to go back again to that one. And we did this really extensive rec run, is what we were calling it, using that kind of mobile operation system to get that outer area. Next slide, please. So just focusing on that water column data, this was a really cool aspect, I thought. So like I said, we collected multi-beam water column backscatter over areas of wrecks or potential targets. And I processed that data and supported the ROV operations. And so as we were preparing to do ROV work after the mapping leg was done, I processed this one over this known wreck. And I saw this persistent feature that was coming off the edge of the wreck, and it wasn't superstructure and it wasn't mass or anything. We weren't sure what it was, but it was very much there. It was very real. And I showed it to the ROV pilots. And then when we got down there, it in fact was real. It was a mooring line that was not coming up to the surface, but had been sunk on the other side of the ship. So it was creating this big arch or like catenary through the water column. Which nobody expected to be there. So it was great pre-knowledge before we sent the ROVs into a potentially dangerous situation to know that that was there. And that was all, again, visible in the multi-beam water column data. Next slide, please. And here's another example, and of course I forget which wreck this is, but this one was also a line with a float at the top. So that plastic thing at the top in the images is what you're seeing. It's a really bright return in the image on the left. So again, just really helpful to have in support of the ROV operations to have a better idea of what you're facing before you put your ROV in the water. Next slide, please. So in summary, between the two expeditions and accounting for overlap, we did a combined 224 square kilometers. This data will be used for many purposes in the sanctuary: high resolution bathymetry, backscatter for archaeological purposes, habitat mapping, and geological interpretation. And I think it was a great example of the benefits of acquiring water column data with your sonar, especially over artifacts like this. And if you're looking at the image at the bottom, that's looking out through the control van with the back door open. And this is when we had a early morning solar eclipse and just some really beautiful sky with Ben kind of shadowing in the foreground there. Just a great picture. And to my last slide, please. So we would both, Steph and I would like to acknowledge the rest of the team. It was a big team of helpers that came in and out, and we're all willing to go out on the 3011 and do sound speed casts all day. John Hughes Clark and Tom Weber for taking a look at our data really quickly and short notice. The ROV expedition team, which put us on the US Coast Guard cutter Mobile Bay. The captain and crew were fantastic, and we worked with an ROV team from, I believe, the University of North Carolina. The 2019 team who laid the foundation for our continued work. Friends of Thunder Bay National Marine Sanctuary who were so supportive, willing to do pretty much anything for us, and were so interested in what we were doing. And Rogers City Marina for being so very accommodating to all of our needs as we sat there for 2 weeks mapping. And that's the end. Thank you for your attention. And I guess Steph and I can take questions if there are any.
No, great. Thanks, Erin. Thanks, Stephanie. It's always fascinating to see what's going on in that part of the Great Lakes. And so one thing when I looked at the last shipwreck image that you had presented, as we do work there, we see these carpets and very thick carpets of quagga mussel on the bottom of the lakes now. And so the perspective of how is that influencing your backscatter as you're moving across these sometimes very unique sites? And how is it limiting your ability to characterize the sea floor today as it might not have been 20 years ago?
Well, I can start to address the backscatter question. They don't show up as bright as I think I would have thought they would have. But I guess because we have the bathymetry, it's very clear, it's wreck. But yeah, you're probably right. It's probably shadowing a lot of the geology that would be showing up more prominently if that carpet of mussels was not there. But that's a great question. I haven't done any interpretation. I just kind of glanced at the data. Do see some high backscatter, but now that I think about it, it is kind of very generally lower than I would anticipate without as much variation. Steph, did you have anything to add to that?
Goodness, I don't think so. I guess as far as the backscatter, how it would be reflected in the backscatter, I don't have the knowledge to answer, but I do think that that is a reason to combine our, different types of technologies in our survey efforts because of the dynamic nature of what we're surveying, whether it's the invasive mussels that who knows what's happening with, as they're going deeper, and then as the water is warming because of climate change, how is that going to affect them? So with the dynamic nature of the very ecosystem that we're surveying, we need to be flexible in our tools.
We've had a couple of questions come in now, and one thing I'll start with is they want to know, someone's asking about the difference between water column and backscatter. So if you could explain the difference between those two.
Sure. Well, they're both backscatter. So when we're talking about backscatter, most people are talking about lakebed or seabed backscatter. So that's the intensity of the return coming from that hard interface of the bottom, right? But water column is also backscatter. So they're both just showing the intensity of return somewhere. And so when we send out that pulse of information, if it hits a target, it's going to send back energy, and so backscatter, right? It's just not that, doesn't make that grayscale map that we're used to seeing of the seafloor or lake bed, but tells us that there is some target in the water column that's reflecting back energy. So the difference just being how we think about them or display them, but they're both all about intensity of the returns and both very useful for different reasons.
Mm-hmm. And another question about the range for the Bluetooth for controlling Ben. How close did you have to be? It looked pretty close, but was that?
It was, yeah, Steph was the expert on that because she was often driving the 3011. But that Bluetooth connection we only used to transfer the CTD cast. So Steph, do you remember how close we had to get for that?
We learned that we didn't have to get as close as we thought, which was good.
Okay.
That one image of me driving the small boat, the 3011, we didn't need to be that close to Ben. So I would say 50 feet was and which is pretty darn close when you're moving at a few knots there, but not super duper close, but maybe about 50 to 100 feet seemed to be the range.
Yeah. And then we had another question with regards to the chase boat and whether or not there was thought of adding additional survey gear to the chase boat to sort of double your coverage opportunity.
We did think of that. That would have been a good idea. I guess we thought of it after the fact, really. So definitely something to add to the next time, because I believe, Erin, what do you think? The chase boat ended up spending more time on the water than we had expected. So once we realized that, we thought, well, geez, we should put some tools on this guy.
Yeah, it spent way more time, a ridiculous amount of time. And I thank you, Steph, and the rest of our team. But we also really recognize that Ben really needs to come up with some solution to get its own sound speed profiles, because it was, just too much labor for an autonomous vessel. And yeah, just great support from you guys.